Okay, so let's get to writing a proof. You must write a justification or reason for each step in your proof. And the justifications and reasons must be either mathematical definitions that we learned, postulates, mathematical properties, and or theorems. The only theorem you know right now is the Pythagorean theorem, but we'll get to theorems soon. Now, we did learn some definitions at the very start of the school year. These are the definitions that we've already learned, and you should already know and have an understanding of. Now, the most important definitions that you should know that we will probably use a lot is segment and angle bisector. Remember, this is, if we're talking about a segment bisector, then it's a ray, segment, or line that intersects a segment right in the middle of it. If it's an angle, same thing. It would be a ray, segment, or line that intersects the angle right in the middle of it. Another key one that you would need to know is definition of congruence, or congruent, which means that two segments or angles are exactly the same. Another one we will use a lot is definition of a midpoint. That's a point that divides the segment into two congruent segments. We also will use parallel lines. Definition of parallel lines is they're lines that are coplanar and do not intersect. Definition of perpendicular lines are lines that intersect at right angles or 90-degree angles. Right angle. Definition of a right angle is an angle whose measure is 90 degrees. A straight angle is an angle whose measures 180 degrees. So these will be ones that we frequently use. So let's get started. There will be sometimes in your proof where we go from saying two segments are congruent to saying that they're equal. This is the definition, and I am fully okay with you abbreviating. So definition of congruence. And I just use the symbol of congruence. Now, if we're going back where it's saying that two segments are equal and now they're congruent, that's still the definition of congruence. And now, the reason why we would need to change the segments being congruent into the segments being equal would be something like if we were using numbers. And we needed to substitute numbers into our segment lengths. Then we would need them to be equal. We cannot substitute numbers into our segments when they have the congruent symbol. So this is something that we will do a lot this year, is changing from segments being congruent to segments being equal. And now for number 3 and 4, sorry, this diagram is for a different question, so ignore this diagram for right now. For number 3, I'm saying that the measures of two angles are equal, and now I'm saying that they're congruent. That's the same exact thing, definition of congruence. And if I was going backwards, if I said that the two angles were congruent and now their measures are equal, that would also be definition of congruence. So whenever you're going from saying things are congruent to saying that they're equal, or vice versa, your reasoning or your justification is the definition of congruence. And again, the reason why we want to transition between those two is when we're dealing with numbers. All right, so given E is the midpoint of BD, let's draw ourselves a picture. So we have segment BD, and E is the midpoint, meaning that BE and ED are congruent. That's our conclusion. And so the reason why is because that's the definition of a midpoint. Totally okay with you abbreviating midpoint to this. All right. The picture that you saw on this page, which is fixed on yours, is the one that's for the next one. So we are given that RU and UN are congruent on this diagram, and we are saying that U is the midpoint of Rn. That's also the definition of the midpoint. A midpoint is something that cuts a segment into two congruent segments. Ray BD bisects angle ABC. So if I drew myself a picture to dictate this, it would look like this, and ABD, angle ABD is congruent to angle CBD. That's the definition of an angle bisector. You can use the angle symbol for angle. All right, next, AB is perpendicular to DE, intersecting at point C. So I have segment AB intersecting segment DE. I guess I drew lines, not segments, but that's okay. And C is the intersection point. And we know that angle ACD is considered a right angle. And that's because perpendicular lines create right angles. So that's the definition of perpendicular lines. You can use the symbol for perpendicular. All right, we're given that the measure of angle ABC equals 180. The reason why we used measure of angle ABC is because we were dealing with numbers. So we'll never use just angle ABC is congruent to 180. It's going to be the measure of angle ABC is equal to 180. We can conclude that angle ABC is a straight line, and that is because if we know that an angle is 180 degrees, then that's the definition of a straight angle or straight line, same thing. All right, so some postulates that we learned that will be important for a lot of proofs that we do this year. The segment addition postulate, which means that the sum of the parts of a segment equal a whole, and the angle addition postulate, the sum of the parts of the angle equal the whole. So, number 9, we are given A is in the interior of angle GLD. What that means is that we have angle GLD. Now, it doesn't say that angle A, or it doesn't say that point A is exactly in the middle, so it might be over here. And it looks something like this. So they're saying that if we take the measure of angle GLA plus the measure of angle ALD, that would equal the measure of the whole angle, and that's because of the angle addition postulate. Now, again, the reason why we're using measures is because we're setting up an equation, and with equations, we do not use congruent symbols, so we need to use the measure of the angles. And you can abbreviate angle addition postulate like this, or if you want to draw an angle instead of writing the word angle, that's fine. Great. Now we're going to make our conclusions and our justifications. And this is where it gets complicated, but we can do it. We're going to get through it together. The only thing I can say, given that TO and AN are congruent to each other, is I can also say that they're equal. And remember, when I go from congruence to saying something's equal, that's the definition of congruence. We are given that E is the midpoint of BD. So the only thing that we would be able to say is that BE is congruent to BD. We cannot say that they're equal yet. We first have to go to congruency, because that is the definition of the midpoint. All right. AT bisects angle MAH. So the only thing that we can say is that angle MAT is congruent to angle TAH, and that's the definition of an angle bisector. And ignore that drawing on this page. On your page, it's correct. All right, so number 13, the only conclusion that I can make is that the measure of angle 6 plus the measure of angle 5 is equal to the measure of angle MUS. And that's the angle addition postulate. I'm going to abbreviate this. You could use that the measure of angle 6 plus the measure of angle 5 equals 180, because the only thing that you are allowed to assume in geometry is that if a line looks straight, then it is straight. And so that would be still angle addition postulate there. All right, looking at that figure on this page that's on your correct page, we do not know that F's directly in the middle, and we cannot assume that. So we cannot say that F is the midpoint. The only thing that we can say here is that if I take EF, and notice I'm not putting the segment bar above it, plus FG, that would equal EG. The reason why I'm not putting the segment bar above it is because I'm writing an equation, and we never put the segment bars in our equations. We only use segment bars when we're using the congruent symbol. This was just the segment addition postulate, so I'm going to abbreviate. Okay, we are given that the measure of angle ABC is equal to the measure of angle HIJ. The only thing that we can conclude is that angle ABC is congruent to angle HIJ. That's the definition of congruence. Some of you might assume that number 16 is a right angle, but we cannot assume right angles in geometry. Only if we were given that little box can we state that this is a right angle. So the only thing that we're allowed to say here is that the measure of angle FED plus the measure of angle GED equals the whole angle, the measure of angle FEG, and that is the angle addition postulate. And then number 17, we're given that the measure of angle ABC is 90 degrees, which means that angle ABC is a right angle. That's the definition of a right angle. So you can say this, or you can say that IL bisects angle MIK, and this is the definition of an angle bisector. I'm going to have you ignore that last conclusion and justification because there is no problem there.